We've all seen this standard model in science class, showing the sun and planets in a neat, orderly row. Using small, equal distances fits everything on a page, but gives a misleading idea of the actual room out there. We tend to imagine that standing on the closest planet, Mercury, would be like standing right next to a campfire. You'd expect the sun to loom over the horizon, filling the entire sky with a wall of fire. In reality, Mercury is still quite a long way off. From its surface, the sun appears only about 3 times larger than what you see from your backyard on Earth. Our mental maps of the sky are often crowded because it's hard to visualize the sheer amount of empty space between every planetary body. Let's try to see the real scale. If we shrink the sun down to the size of a standard basketball and place it in the center of a busy downtown square, the planets become much smaller and much further away. At this scale, Mercury is a single grain of sand. To place it correctly, you'd have to walk about 30 steps away from that basketball. Venus and Earth are slightly larger, roughly the size of pinheads. To find them, you'd have to walk a full city block away from the center of the square. Mars is another grain of sand, resting just a couple of blocks further down that same street. These 4 inner planets are like a small, clustered neighborhood. Because they are all within a few minutes' walk of each other, it creates a sense that the rest of the solar system is just as dense. It's natural to expect that the next planet, Jupiter, is sitting just another block or 2 down the road. But here, the scale changes. The distances between the planets stop being a short walk and start becoming much longer, stretching out into massive, widening gaps. To find Jupiter on our city map, you travel an entire mile from that basketball sun. Jupiter is a marble, 11 times wider than our pinhead-sized Earth. But even a planet that large is lost in the emptiness separating it from its neighbors. This vast void is why deep space exploration is so difficult. Crossing that mile requires an incredible amount of fuel, time, and careful planning just to hit a target the size of a marble. It's the difference between a quick commute and a major expedition. Every mission we send past Mars has to be built to survive months or years of traveling through total silence. Moving from a Mars mission to a Jupiter mission is a massive leap. You are leaving the clustered neighborhood and heading out into the absolute emptiness of the outer solar system. If we keep going to reach Neptune, we find a marble that's slightly smaller than Jupiter. At our city scale, Neptune sits several miles away, tucked into a distant suburb or even the next town over. When we pull away from our imaginary city and look at the real solar system, the orbital lines vanish. The reality is just a few microscopic specks of rock and gas, scattered across an exponentially massive, quiet void. A moment of wonder. These distances are so vast that they act as a buffer. In a universe where giant stars explode and galaxies collide, our solar system is so spread out that we are almost impossible to hit. The night sky is a massive ocean of nothingness. This immense emptiness keeps our tiny world isolated, leaving us tucked away in a quiet, safe corner of the cosmos.